The Sporland division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporland's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporland.com and navigate to the Resource Center. Parker Sporland, leading the charge.
I actually have an idea, but we'll talk about it in a minute. Yeah, so
not recorded.
Well, no, I just meant like what we're gonna do for the week, because I was thinking about it before, and I was like, oh, what are we gonna do today? And because I had not wanted to get Wetzeled, and I inadvertently got Wetzeled because I looked at the flight, and yeah, it didn't get canceled, didn't even get delayed, took off normal. So that's awesome. So I'm driving from Colorado back down to Dallas. And and having yogurt is not, that's not, there's nothing wrong with that.
It's gay.
No, it's not.
It's gay.
You telling me it's going to be 2 more seconds, that's gayer.
It's really gay.
So what are you up to this week, man?
Oh, just watching the world burn.
That bad?
Yep.
Why is it that bad?
I don't know.
Explain.
It's just people not doing their job. Yeah, it's just people not doing their job. So what are we talking about this week?
I don't know. I was going to do, thinking about doing a little bit of Novar stuff.
Ugh, gross.
Then if you don't want to do that, we can do something else.
Fine, we could do some Novar stuff.
All right. I was just going to share something and then basically run through certain things of it, because there was a gentleman I was walking through some stuff with. It's amazing. Even I was working with some Walmart guys this week. They just need some help on some stuff. So I figured this would be a nice thing to do as far as showing them some of the stuff, as far as some of the addressing on some of the boards, how to locate some of the boards, what the boards are actually called, what the boards are doing, and all that other happy horse stuff. So if you're okay, I know that's a bad word for you, but
no, that's fine. Let's do it.
Okay. Oh, puppies. We'll start with the Spectrum stuff.
Sure.
Because there's still a bunch of it out there. Because there's still boards out there that are still Spectrum. And then we'll talk about the IXOs. I just want to make sure I have it queued up. I'll look like an asset. There we go. That'll work. All right. Let me just minimize that for a second. Share. Nope, that's to share the whole thing. I'm sorry it's so early in the morning. You were up though. Window, Chrome tab. No. Just share the whole window of the. There we go. Share. Because I had it minimized. All right, we'll start with CIM boards. With that, how will we do that?
Gross. All right. So CIM boards. This is the old school Novar input cans. They're real long. They're 24 volt DC powered. Usually they're like in the most terrible spots ever, like on top of walk-ins or like in a closet.
They do it because they run the sensors to it, right? So instead of having to whatever, they just run everything centrally. But yeah, they can be powered with both volts AC and DC if you look right here.
90% of the time you're going to see them DC, and they come out of usually off the rack house power, usually off this spectrum base. So
Yep.
they're usually coming off the spectrum base. So you're going to have some selectable inputs in here. So your analog inputs, generally these are 4 to 20 milliamp inputs.
Yeah, they use those special sensors. There is a way to calibrate these, and I always forget. It has something to do with
you push the button.
Yeah, so you have to take the front cover off, which is 2 Phillips screws, and then that accesses this whole thing right here. And I think you select it on the actual sensor that we're calibrating, but you have to have the sensor in actual ice water, correct?
Yeah, they're the only ones that make you ice water bath test sensors, which is ridiculous.
But the way they do that one is the reason why, because you can't put an offset in it. So at least they know if you have it in ice water, it's exactly 32 degrees, so they can calibrate it.
I think it can go plus or minus 4 degrees.
Oh, really?
Yeah, it's the most it'll go. So it'll let you calibrate off of that, plus or minus. I believe 4 degrees. Don't hold me to it, Dylan. And you said the wrong thing.
You're really butthurt about that.
So it's annoying. So generally with these, you're going to have the Novar low temp spectrum sensors that kind of look like a little sensor, and then a short piece of like inch or two, half inch of wire exposed. Then it goes with the gray cable. So generally, you don't have any other sensors on here. They can use different sensors on here, I believe.
I was told that there's a little diode at the end of there. That's why you can't check resistances on those. There's a diode at the end of there, and that's what that piece of shrink wrap is on the end of the sensor. It's not just the sensor lead, but there's actually like a diode or something on there. So it's like a very special sensor. It's not like a regular standard. You can't check resistance on it. That's why there's no resistance temperature chart. Typically, you'll have like the Novar 2K sensors. They're 2K sensors, so they'll be 2K at 77 degrees, and then and so they go up and down from there. But same thing with 10K and whatever else. Like I said, Novar uses these special ones for the CIM boards. And so you can't do the old resistance check to make sure that they're actually calibrated. So every single spectrum board out there has only a list of addresses that can do. This one can be listed from 0 to 63.
Yeah, this is old school stuff. They should be pretty much dead by now.
No, there's tons of them out there.
There's tons of them out there, but what I'm saying is you shouldn't be seeing new stuff with them.
Yeah. Oh, there you go. Kevin, you weren't right. So Dylan, if you're listening, it says display will show error if outside plus or minus 4 degrees.
Yeah, plus or minus 4 degrees. That's what I said.
I know. I'm just making sure that Dylan doesn't have to get off his couch and go through and read whatever. So, we're showing you right there.
He can't get off the couch right now.
So these boards, so we had to look yesterday. So a lot of people are still a lot of contractors are still doing the conversions they're putting a lot of the IXO boards on here on the new, if they're doing the ES1 or the ES3. You see the new controller where it's basically
ES47 with the small screen still.
It still has a small no, the one that has a small screen, but it's back to doing the big base. You know what I'm talking about? It was just someone was supposed to I think it's called the ES3 because someone was like, where'd the ES2 go? Because they literally went from ES1 to this ES3.
God forbid we put a screen on that's bigger than 2.5 inches by 2.5 inches.
Listen, then you got to redo the mapping. Who wants to do that? So anyway, if you're doing 24 volts AC, these things are 2 VA. Usually Novar is famous for, or Honeywell's famous for giving you a 40 VA transformer. So you can do up to 20 modules on that one transformer. Also gives you the communication, gives you, if it's, uses Novar glass diode sensor. See, there's the diode ones that we're talking about. Sensor distance. What are you texting away over there? I can't even see you, but I can hear you.
I'm playing project manager.
Oh, stupid. Sensor distance, 100 feet. Second 100 is 1 degree. Oh, okay. So if you have it more than 100 feet, you'll have another 100 feet will give you a 1 degree off. So that's why I probably have the calibration method over there. Terminal 13 and 15 is 5 volt DC supply and then return. Sensor. So there is a small digital display if you actually look on top here.
Very small. Very tiny.
Teeny tiny. And so basically that's where it'll show your errors. It'll also show you the temperature. So you can actually go to the actual board and rifle through So you can have someone spray check the sensor if you really want with duster and just be up on top of the board and see which one that make sure they're hit the right one.
I had somebody having meltdown about that, by the way, the other day.
Who?
Somebody, you're spraying chemicals in the case.
Okay, there's refrigerant in the case.
Fucking shut up and get away from me.
There's
There's so many chemicals on all the food anyway.
That's awful to say, but true. But no. All right. So every time, so we're not supposed to check refrigerant pressures apparently now at the cases.
What?
You hook up to your gauges, you're going to have a little de minimis release. See, apparently now you just can't even hook up your gauges.
You can't tell me the RO water spraying on the produce isn't going to cause cancer in 20 years.
No, but everything that case made of apparently in California is going to give you cancer. You know what I mean? Every single part. I looked over at a car the other day when I was in Cali and I was like, this windshield might give you cancer. What? How's that thing?
Literally every part of it. The case is made out of foam.
Damn, I don't know if I'm going to edit all that shit out. I hate you. All right, let me go look at that listen again. So the sensor calibration method for the CIMs. Place a sensor in an insulated container containing crushed ice and water. Use the PB2 button to verify the proper input via configuration. Allow the temperature reading to stabilize for 60 seconds. Press and hold the PB1 to calibrate. And then the display should read CAL, which actually calibrates it. After approximately 15 seconds, display should read the calibrated temperature sensor, which should be 32 degrees. Release PB1, and then you can calibrate. It should be within 4 degrees. If it's not calibrated within the 4 degrees, excuse me, then it's going to read error, and then you have to replace the sensor. There's nothing you can do about it at that point. Yeah.
Yeah, they're fairly easy to deal with. Check and comm, it's usually like 2.2 to 2.3 from left pin to center, 2.3 to 2.6-ish pin to center. You should have it with it unplugged, the comm, all wires off and the comm wires on. Fairly simple, fairly easy modules. They either communicate or they don't communicate.
Yeah, so the only... Go ahead, sorry.
You usually know in between.
So there's also dip switches on there. If there's anything else, because we have to be able to tell what the address is. So dip switch 1 through 6 are for addressing. Novar. So if you got six dip switches, that 1 would have a value of 1, 2 would have a value of 2, 3 has a value of 4, 4 has a value of 8, 5 has a value of 16, and then 6 has a value of 32. They have some modules that have more DP switches, like the IXOs we're going to talk about in a little bit. They go up to 64 and then 128 value for every single dip switch. Dip switch 70 is used for the baud rate, which is either you put it for 9600 if it's on the Spectrum network, or I think if you have these up to the Logix, like the rooftop unit controllers, that's when you move it to in the off position. And I don't know what dip switch 8 is used for. It just says used for protocol. I don't know what that means. Doesn't mean it's used for Houseman protocol, but that's what.
My only complaint with them, and
I love how you start a conversation. You're like, my only complaint, but go ahead, continue.
Why do you make an open sensor read -40 so it shuts the refrigeration off? Then Danfoss -58, Parker -58. Like, it shuts the refrigeration off. Why does everybody an open sensor go to -58? That seems like a terrible idea. Like, why not make it read 66.5 and not shut the refrigeration off? It seems like very counterproductive.
Then you have a problem with the refrigeration, right?
Yeah, and nobody catches it, and then they throw away all the food.
Wait a minute. What does the resistance go down? I forget.
Yes.
The resistance goes down.
Same thing with CPC. They're Copeland, and Copeland just reads open sensor. It doesn't actually show a value.
Yeah, we need to read open sensor. Put a little bit more effort into your programming, guys, when you're doing this.
But no, but it's the truth, though. You think about it, Danfoss reads -58, shuts off of the case. Yeah. Microthermal, same thing. Novar, same thing. It shuts down the refrigeration. But I don't understand why you'd want to, why not just make an open sensor read high or an open sensor read?
Just make it read open sensor.
That goes back to the thing that nothing should be cycling off temperature anyway.
We should have a section in here. You know what grinds my gears?
Yeah.
Why does every single sensor digital input control, like a level control, one thing red bad, one thing good, green is bad? Make up your fucking mind. There should be.
It's the truth. It's the truth. Why is the red light on is good, the red light on is bad? Come on. And then you get the same manufacturer. Some of them change the colors. Like this one's got a green light. Like, who the wants a red light for things? Red means bad. Like,
red means bad. So stop.
Yeah, like you should use a green light. Green means go. Green is good.
Good. It's
green
good.
Is money.
We got level. No, so Cure One does the same thing because they're like, when it's red, it has a level. Okay. But then there's other ones where if it blinks 5 times, it has a level. Like
that's retarded. That's ridiculous.
And usually on the other ones it means blinky bad. You have to remember it. Like on the picture sensors, when they blink profusely, fucking bad. Yeah.
Or it's just connected from the compressor. Like it's seeing light somehow. Make up your damn mind and quit making it like 75 different things.
We have to have an INT 276 GR. We have to have an INT 267 LC.
Why don't you make them heated so they stop shorting out?
They're rated for negative 40 degrees or some shit.
Oh yeah, I'm telling you, when they're on the flash tank and it's sweating and they short out.
I'm not arguing with you. I'm just telling you what they're rated for.
Just smother them in dielectric grease.
Well, do what Carnot does and just pack that shit in there. Okay.
They get the trowel out and just clean over the top with the fucking bits or compressors. I had to rewire 15 on a rack one time. And I swear to God, I threw away my fucking shirt, my pants, like all my tools were disgusting. I was spraying them down brake. I went with 2 or 3 cans of brake cleaner, just cleaning my tools off. I probably got cancer in California from that. But
Canadians don't have cancer; they have public health care.
Oh Jesus Christ! That one's definitely gonna have to get fucking taken out.
No, it's true. I mean, they have public health care.
Today's episode is sponsored by the RefRushield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
All right. Anyway. We have to do a section now of grinds my gears. Something that's really pissed you off every fucking week. Rack input modules.
All right, so guys, these are rack input modules. This is more of a canned program thing. So you're going to have a certain suction pressure. You have satellite suction pressure. You have your compressor proof inputs. You have your suction temperatures, your random compressor discharge temperatures, some current, your CTs, which I don't know why everybody doesn't do. I think having that data is fucking awesome.
Just remember, when you have to do a conversion, there's a different module that you actually have to use. So there's an IXO input, an IXO output, but then there's also an IXO CT. So if you have to do a conversion, they're going to give you a whole bunch of boards. Make sure you have the IXO CT board.
So why don't you just change the damn CTs to ones that you don't need the special 4 to 20 milliamp CTs?
Because then you'd have to do a 3 liter, right? You'd have to do 3 leads. Those are only 2 leads.
No, you don't. All the CTs we put in.
You're right.
They self-generate power.
Yeah, from the inductance.
Yeah. So CTs, guys, be very careful putting these in, or you end up like me last week and blow the main to the rack house.
How about do it when you don't have the power on, dickhead?
I didn't have the power on. I had 2 compressors off next to me, and a screw flung 3 compressors away when I took it out with the impact and landed across L1 and L2.
If you would have did it without the power on, you wouldn't have cut the main. Okay, real quick before you get continuing, the addressing for these things are done with these little two little
pin.
pins. They're almost like if you're old like me and maybe fucked around with a computer on the hard drives where you had to select the computer, either master or slave, you had to move that pin around, or the termination jumpers on the multiflex board.
They're actually the same jumpers as the termination jumpers on the multiflex board. So if you lose them and you have a multiflex board, you could steal them from there. Guys, these boards are simple, same as the other ones, like 2 to 3 volts DC for your comm on here. So 2.3 to 2.6 volts DC for your comm. They're going to get powered, same thing, off of a common transformer or DC power supply. And you're going to have compressor inputs for hot gas. They lock out your compressors. Now, I will admit the Spectrum controller is the greatest Novar controller ever made, and the keypad one. And you could go into the modules and actually force the inputs and force the outputs on this and see your inputs and outputs and check them that way. It's a lot faster doing it that way. And then you have your analogs on your right-hand side. So you get your analogs in there. Some of these are somewhat configurable. Like we did a bunch of them, the suction pressure 2s, we ended up using for liquid levels when we did a bunch of liquid level installs for Walmart. So just be aware that if you see a liquid level on suction pressure 2, it may not be suction pressure 2. It's the liquid level.
Yeah, gotcha. You only have to use that if you had the same thing. You could actually have suction pressure 1, suction pressure 2 if you have a split temperature rack, and then it would be suction pressure 3 would be your leaky level.
Yeah. So, guys, now even one thing that's weird about Novar. Novar is like microthermal, and in the old 500 board sense, things are canned, meaning like this board does one job. It does the rack inputs, doesn't do anything else. And same with your compressor output module. That board does the compressors only. It's just like microthermal. Like it is a canned board. It does one job only.
Yeah. Same thing with the CCMs, right?
Yep.
CCMs is a condenser control module, and they're not really original with the naming nomenclature. So no, they're not though. Like it's rack input module. What is it doing? I don't know. Probably all the rack inputs. So it's wasn't a slander at it. Just that's what I'm saying. It is what it is. But so this gives you all the information. So these boards have 7 VA. So once again, if you're having to do some conversions right there, to change that one board out, like with all the inputs that it does have, you're talking 1, 2, 3, 4. Essentially 5 different boards, 5 different new XIO boards in order to replace that son bitch out. So
it's not just 5 XIOs.
1 here.
Yeah, but they're doing combos when we're doing them. Like they'll do input-output combos.
There's no outputs on here. It's all inputs.
Yeah, but when they do them, the new stuff is combined.
Unless you have a 16, because the CT board is one by itself, right?
Yeah.
And then if you have 2, because all they did was give this cat 8s. So you got 1 8 here, you got 6 here, and you got 1, 2, 3, 4, 5, 6.
The only thing nice is
so 4. It would take 1, 2, 3, 4, 5 different boards.
Usually they're condensing it, but like they're getting rid of the compressor module and integrating it into the boards. Oh. They've been XIOs, so they're
not on the scheme that we got.
You got hosed.
Because they figure it out via Novar or Honeywell, whatever you want to call them. They figure out how they are going to have it programmed, and then they give you an IO list.
Yeah, the one we did had like input-output boards to replace these. So like it was 8 inputs at the top, 4 outputs at the bottom, 8 inputs at the top, 4 outputs. So we lost 2 boards and gained 2 boards. So in the board train, so it essentially ended up being the same length.
Yeah, no, I get you. I'm just saying, if you had to like straight up replace just this board by itself, you would have to use 5 different XIO input boards.
That's why you just find one.
Oh, love of Christ.
What? Acid Technologies has them. They're reclaiming them.
Yeah. Input. Yeah, so these are 7 VA. It's as you go through, you'll find that usually the more crazy inputs you have because you're using voltage for all those, the VA goes up. So like the newer
one thing to note is the transformers. are 24 volts powered. So they're 24 volt DC powered. So I think it's 7 to 24. If you look at the transducers, they're a lot like Danfoss. They have a big range in there, but they are 24 volt DC powered.
Yes. Yeah, because we'll get down to the CCM, but like we had a CCM board where the power supply went bad, and I just replaced it out with a Danfoss power supply because that thing's it's so versatile. I've used it for so many different applications.
Those things are great. Like that is gonna be up there with the drives. That is gonna be one of Danfoss's best things. Like those power supplies are amazing.
Yeah, so you can see right here. So red power, they're using 24 volts. So the range is still either 1 on Novar shit. Anyway, the Spectrum stuff, it's 1 to 5. So there's that. All right. So what's
and they had to make it 0 to 400, so you couldn't use a Danfoss at 0 to 500.
They don't want you to. They want you to use their stuff. They want their pretty gray one, right? All right.
Except so Spectrum makes them all basically.
No, they don't. You know what? Someone yelled at us for the other day for you saying some shit like that. And you're like, yo, what did you say? Bacharach makes all the leak detectors. And then someone comes up and says, how about Corral? Corral makes their own. I fucking hate you.
Bacharach's a monopoly and they're controlling.
You're just talking about the leak detectors, right?
Yeah. Okay.
Because Corral makes a good controller. It's versatile. You can use it on a lot of different stuff. All right. Compressor output module. Like I said, here's that original nomenclature for verbiage.
What really grinds my gears about these is they're not fused.
Yeah, it's silly. So then the output blows out, and then you'll see random ones just dropped. So these can only be addressed from 16 to 19. So that's why if you look right over yonder, like there's only available to have potentially for 16, 17, 18, 19. You can only have 4 of them on there on one loop.
Which has a lot of boards.
It is.
Guys, with these, fairly simple. Light is on, the compressor is off.
How about on loaders? How's that work?
On loaders is the other way around.
Okay.
Handoff auto switches, they work great. I actually love that feature. The HOA switches, so if you're trying to pump down a rack, you could throw the hand switch and pump it down. And so that way the controller isn't cutting it out.
Yeah.
Works great. Those relays you can get at Micro Center usually. So if you have one and you want to replace it, it's pretty easy to replace at Micro Center. What are you smiling about?
Nothing.
Oh.
I'm smiling.
I don't like that.
You don't like that I'm smiling?
Nothing good ever comes from that. So you can get it from Micro Center or some electronics place. You can change these relays fairly easy if you know how to use a soldering gun. But these control compressors and unloaders. That's it, guys. Compressors and unloaders. Compressor control module.
Gotcha. All right. And so these ones, those are 20 VA, and it's probably just because there's freaking 10 different outputs on it. Right?
Yep.
Probably because that's why the VA is so damn large on this one. So the outputs, Form B. Okay. So the first set is Form B.
So it's either open or closed. That's it.
And then Form C is from 6 to 10.
Which is going to be normally open, normally closed. So
in common. Yep. And that's really it. There's nothing really that much more that we can actually talk about with that shit. Moving on. Let's see. Remove that bitch for a second. What's about a girl in a party?
I have no idea what that was.
Here we go. The next original board. I didn't think this was going to take this long. We're going to have to do another one for the IXOs.
Yeah.
No, I'm serious. We're already hitting 30 minutes here, kid. Add a stage. Rack output module. Go ahead. You were doing such a good job explaining. Go ahead, keep going.
You already did this. Oh, it's a rack output module. Never mind.
No, we didn't do this.
This is the this is the Swiss Army knife of Novar, basically. So this is your rack output module. So this is used for splitting split valves, defrost, any random relay stuff. It's going to be on or off inputs. They're all Form Cs. So this is going to control generally in your defrost cabinet. So 24 volts powered. You got your module power, you got a fuse on here, and then you have your jumper positions with your addresses on there. This is the same thing. Light is off, it's calling. Light is on, not calling.
Yeah, except for the only difference is here, there are 16 outputs. So these are typically used for your EPRs, liquid line solenoids, evaporators, defrosts, all the other shit.
Really sucks changing these over to CPC board or like Copeland boards or like Danfoss where you have 8 and it's almost the same length.
Yeah. Yeah, because you have to add double the amount of outputs. Usually the CPC boards that has
they make a 16/16, but it's only for
lighting. Yeah, it's
lighting.
only for lighting.
Yeah,
no,
don't put 120 in those.
You learned that?
They don't last.
All right, let's go down to the next page so we can go over some of the stuff. And like I said, it's going to be fairly similar to the other one. So for these are all, if I'm not mistaken, those are all Form B contacts, right?
For what?
They're
Those are all Form
C. Yeah, that's right. Because they have to have the normally open, normally closed. You know what I mean? Because you have to use it for liquid line solenoids, evaporators, hot gas, blah, 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 blah. Dual temp solenoids. Yeah, you can use that for that as well. So if you have a switch hooked up to a DI board somewhere, you can basically switch the DI board, tells Novar, hey, switch that bitch into dual temp. But have you seen that been done? I don't think I've ever seen that been done.
Yeah, I just converted a Danfoss store this week with that.
From Danfoss to Novar? Or
no, Danfoss to Copeland.
No, I've seen it done on Danfoss. I've seen it done on Copeland, but I've never seen it done on Novar. Is what I was saying.
Listen, I take the Danfoss out. I put the Copeland in. I put the Copeland in. I put the Danfoss in. I take the Copeland out. It's just like a never-ending circle.
Oh, so the only last thing that I want to bring up. So the addresses from this go from 32 to 39. So just be aware of that. So it just makes it easy. Yeah, that's all. I just want to add that little bit. And yeah, 20 VA because there's so many damn relays. All right, next board to talk about would be the blah, blah, blah. Ooh, here's everyone's favorite. Because when this thing starts failing, especially in the wintertime, everyone has a really...
Oh, yeah.
Lovely. You know what the fuck I'm talking about before I even bring it up.
Oh, shit.
There we go.
Yep, condenser control module, guys. This
CCM.
So... You only get one switch for hand auto on this guy. She's all show or no go. You got your hand auto switch on there. You get your Form C contacts for your fans. Generally, this just controls your fans. It is fans only, and then it's going to have your 24 volts
and the
coming
split.
out for
and the split.
Sometimes, most of the time, you see a split coming out of one of the defrost boards.
Usually being controlled by the VFD. Like they'll send an output somewhere.
Depends on what VFD version you got, because if I just started some VFDs up and they got what they call the dumb drives and the smart drives, they've been putting a lot of dumb drives in lately. So
someone just went through that with me. Actually, we were over at a store and I was like, why? All the fans were on. The VFD was still calling it split because of the compare. I don't know why. I don't even know how, actually, to be honest with you. Because the comparator,
somebody didn't program it right, probably.
So I looked and I was like, oh yeah, the pressure transducer's off. So someone had isolated it and it was reading like 110 because they left pressure on it. And then I was like, check the pressure, and they're like, it's closed. I'm like, open it up. So I'd open it up and it went up to 138 degrees saturated. It was under user defined. And I was like, 407A is the go-to for everything. So I just put it to 407A with 448. And I looked at another drive that was next to it and I was like, because the head pressure on a compound compressor was all the way down to 112 pounds.
Hell yeah.
No, that's bad.
Hell yeah.
That's bad because
efficiency.
Okay, efficiency wise, great, but not so much on the compound compressors. If you don't know,
reads are just going,
they're vibrating to shit. So yeah, so if your head pressure is a minimum, I think the minimum is only like 74 degrees saturated condensing temperature.
I thought it was 70.
I thought it was 74. I don't know. Dylan, you want to check us and see who's right? I'm sure he's fucking typing away now. He's gonna be like,
well, I'm gonna get Brett this time.
Brett was fucking wrong. I don't know. It's either 70 or 74. For some reason, 70. And Jamie's busy doing this right now.
Split the difference.
72. I'm not splitting the difference. It's either 74 or 70. I should say in the Carlisle manual for those specific compound compressors, but I'm pretty sure it's 74. Because normally we go down to 70 with head pressure control, right? I think it's just a touch bit higher. And the reason why is because they're reeded compressors and they want to make sure there's enough pressure differential across them to make sure you get a tight seal so you don't have any blow by on them, blow by on the reeds. As we were talking before, so this will typically have a temperature sensor that will be underneath the first fan.
Allegedly.
It's supposed to be. I don't know why they do it like that, because sometimes they do it because the first fan is always supposed to be the header fan, but they call the first fan not the header fan. They do it. They do the one. Opposite. I don't never understood that. If you look at the condenser strategy, how they have them numbered, they actually have them numbered the way that they want them. But that's stupid because it causes twisting in the metal and such.
Yeah, I don't agree with. And then you get these new condenser OEMs that are mounting the sensors underneath the cabinet and leaving like 40 foot of cable in there, knowing damn I got to move it every time.
Yeah, gotcha.
But no, these are fairly simple, guys. They fail probably more than any of the boards out there.
And I don't know what it is, man. So the pressure transducer will actually go down to the actual to the discharge pressure transducer downstairs.
I'm convinced it's from all the motors shorting out. And when they do, I think they arc and short the relays out, and then it just goes backwards.
It's weird, though, because it usually, like, the biggest failure I see is usually losing the pressure transducer on the bastard.
Yeah, but usually it's when something's shorted on the board itself, and then it takes the 24 volts with it.
So these addresses can only be from 20 to 23? Once again, you have the little jumpies right here.
I would be surprised if you had 3 of them. I mean, it'd be a massive rack.
Yeah. So then the and also the stuff that we're showing, we haven't even talked about it, but communication voltage for this is 2.6 VDC to negative shield, and 2.4 positive shield, form C contacts, 10 amp max. And like I said, so 3-wire transducer, 0 to 400, 1 to 5. So wait a minute, 1 to 5. No, if it
so it gives out 1 to 5 volts DC.
Yeah, and common and blah blah blah, and then you also have the temperature sensor, which is the Novar glass diode sensor.
Is your outdoor air temp sensor, so that's going to be underneath your condenser, telling it to do outdoor air things.
Underneath the first fan that never ever shuts off. Let's see how many more spectrum boards we got. I don't think we have that very many more.
Should this be the Min-IO?
Yeah, maybe. Yep, yay.
So the Min-IO, guys, is the Swiss Army knife for Novar.
You just call it Novar?
Novar.
Is it French?
That's when you want to church it up.
It's like
Charge. So this is the Min-IO. There's black label and white label Min-IO. The comms get labeled or what?
Nothing. I was just
the comms get inverted on the white label Min-IOs, I believe. So to be on the same network. So Min-IO, guys, you got inputs and outputs on here. So you got a combo board, a true combo board. So you could do 10K, 2K, you could do 4 to 20 milliamps. You could do analog outputs. It has analog outputs. You can plays. So this is like a Swiss Army knife of Novar boards. So
it's like
it does
multiplex board.
Yeah. Stop.
It's like what a board should be.
Yeah, this is what everybody else. It's like a Danfoss multiplex board.
Goddamn. Anyway, keep going.
Talk about me. This is you.
That's how you not agree. Shouldn't every single board have the availability where and that's why they went to the new IXO boards.
And Honeywell already had that product out. That is a Honeywell already. You see him. I seen him in a panel the other day.
I know the ES1
is a Honeywell product.
It's a fucking Jace controller.
Yep.
I'm using Jace controller in HVAC forever.
Yep. Yeah.
Continue.
So across the bottom, it matters how these jumpers are at the bottom, and it matters how you wire these, what the input's set up for. If it's set up for resistance, if it's set up for current, meaning like 4 to 20 milliamps, and it matters how you wire it. It matters how the dip switches are.
Very comparable. Those little jumpers are very comparable. If anyone's ever worked on automated logic controllers, ALC, they do something very fucking similar, where you have to have it jumpered over to see what the actual input is.
Yeah. It's fairly simple, 24-volt powered. Same thing with the comm. The white label ones get the comm inverted, I believe. That one I don't remember. I always had this flip-flop it. One of them, the comm
Dylan,
has to be
Dylan,
inverted.
you want to check that out and check him and make sure he's right on
Oh,
that.
my God, you're such a dick.
So
So one of them has to get inverted. So generally when you start going away from spectrum boards, usually the
Yeah.
comm has to get inverted. Just like Copeland when we're dealing with Dixel.
Gotcha. Do small footprint, blah, blah, blah. Chillers, pumps, you can do a lot of stuff. Oh, they don't have any of the drawouts. Oh, we didn't cover this one.
Oh, yeah. The one forgotten. The analog output module.
Yeah, I've seen them in a lot in Sam's Club, but not very much anywhere else.
Generally, you see them driving Sporlan IB boards.
Yeah.
So,
Go ahead.
Back in the day, in Brett's day, they didn't have an EEPR board like Danfoss and Copeland did. So what they did, Novar did, is used Sporlan IB modules, which is a great module to keep in your truck if you ever need something to get you out. I've built high pressure valve controllers out of them. So it's basically taking a 0 to 10 volt signal or a 10 to 0 volt signal and sending it to the Sporlan IB board, and then that board is stepping it proportionally, so off of the 0 to 10 volts. So 0 volts is full closed, 10 volts is full open, depending, and you can invert it. So 10 volts could be full closed or 10 volts could be full open.
Yeah.
It works. They're just using it as an analog signal. Worked great back in Brett's day.
I hate you. These things are older than me. So you can address these from 56 to 63. And it takes, even though it's only doing four variable outputs because it is using that power, it's basically 6.5 VA to power that particular board. You can use it for variable frequency drives, scroll compressors, electronic expansion valves, and then the EEPRs, like he was saying.
Yeah, sometimes you see it on the dumb drives. You see them installed in the drive cabinets. On some of the older stuff.
And I wonder if there's any more that we actually forgot.
Should be about it.
Son of a
What?
bitch. One more. I think so, yeah. Yeah, we're not going to cover any of the HVAC shit. No one cares. Maybe we will. I don't know.
ETM 2024s and ETM 2020s.
No, but we did forget one lone Novar board. Hold on one sec.
Novar.
Novar. That's
what I call it. It's Novar.
I know. I'm just saying. The episode. I'm just going to church up the name. I'm not going to call it Novar.
Quit trying to church it up. 8
okay.
IMs.
Yes. So very similar to the CIMs, except for the fact I don't think that these can take different types of inputs, and these don't have the calibration button.
Yeah, you see these a lot in the drive cabinets for proof and fault signals. So you'll see these installed. They're probably a little cheaper because they don't have the screen on it than the CIMs, but generally you see what?
It doesn't have the calculator screen in there.
Yeah. You make it say boobs on the bottom.
There's only there is 4 segments, so I guess you could. So there's jumpers on there, just like on the. See, is it Mino board or is it Mini IO?
Mini IO. Don't say Minio. That makes you sound ridiculous.
All right. So on the Minio board. So just like on the Minio board, they have
Why
the
do you
jumpers.
keep saying that way? Min IO.
Min IO, because I'm saying it like you say hysterious. Jumpers between JP1 and JP2 basically select if you're doing 4 to 20 milliamps or 1 to 5 volt inputs. And so just on the Minio IO boards, you can select what type of input that you actually put to that. And then it says terminals 13 and 14 cannot be used as inputs because that is just your power supply. Yeah, power supply. And so that's what the jumpers look like a little bit. And they have the same VA rating as the whatchamacallit, the same VA rating as the CIM board, and same addressing scheme. And I think that's going to call it. I think we've done with Novar refrigeration stuff. Novar.
The original.
Novar. I'm sorry. Maybe that it got bougie before I was born.
It's Northern Ohio Video and Audio. Okay, don't forget.
Is that what it is?
Yes. Northern Ohio Video and Audio.
I did not.
Yeah, they used to make radio equipment before.
You're a boomer.
What? You didn't take the class.
You knew that. It's funny because I read in one of the documents that said Ohio. I'm like, wow, to make it in Ohio. I thought everything down Bentonville, but
no. Apparently, you didn't take the class and get certified. I also got almost kicked out of the class because I kept calling it Slopus.
Yeah, I can see that. All right, so what we'll do, because I mean, that was actually pretty good. You were like, fuck this, we don't want to do this. But no, that was actually pretty good. So I guess next week, because it doesn't require me to actually have any stuff with me, we do the XIO boards next week, and then we'll talk a little bit about the ES1. I have no information on the ES3.
We'll see how angry I am next week because going to pre-start that.
Oh, that's right.
that Kroger. So
we're gonna have an edited FTA one.
We'll see how much anger I have.
It should be good. All right. Everyone have a great day, and I'm going to keep trucking along. I'll talk to you guys later. Have a good one.